Due to it being rewritten many times over the centuries, the Bible has some very good information as well as some very poor information residing in its pages. Thus, it's the kind of book that both contractive religious thumping fundamentalists, as well as expansive spiritual philosophers, and perhaps the full spectrum in between, can find some benefit in. In the opening lines of the text, in Genesis, it says something very peculiar. "And God made the firmament, and divided the waters which were under the firmament from the waters which were above the firmament." Waters above? How can such a thing be possible?
When placed over a less dense medium, a liquid layer will typically collapse downwards if it exceeds a certain size, as relative density acting on the lower liquid interface triggers a destabilizing effect called Rayleigh-Taylor instability. Of the many methods that have been developed to prevent the liquid from falling, vertical shaking has proved to be efficient and has therefore been studied in detail. Stabilization is the result of the dynamical averaging effect of the oscillating effective relative density. Vibrations of liquid also induce other paradoxical phenomena, such as the sinking of air bubbles, or the stabilization of heavy objects in columns of fluid at unexpected heights. Here, we take advantage of the excitation resonance of the supporting air layer to perform experiments with large levitating liquid layers up to half a litre in volume and up to 20 centimeters in width. Moreover, we predict theoretically and show experimentally that vertically shaking also creates stable buoyancy positions on the lower interface of the liquid, which behaves as though the relative density force were inverted. Bodies can thus float upside down on the lower interface of the levitating liquid. We use our model to predict the minimum excitation needed to withstand falling of such an inverted floater, which depends on its mass. Experimental observations confirm the possibility of selective falling of heavy bodies. Our findings invite us to rethink all interfacial phenomena in this exotic and counterintuitive stable configuration.
Surface, and you can see this picture was taken at night, and then the clouds appear to be pretty much like glowing in the nighttime sky. This was over Scandinavia. NLCs are also known as polar mesospheric clouds, and that's how I will be referring to them throughout this talk. So polar mesospheric, so they are in the polar regions in the mesosphere. So this gives you a plot of the temperature of the atmosphere versus altitude. You can see in the troposphere, the temperature, of course, it gets colder as we go up in altitude. In the stratosphere, it gets warmer because ozone absorbs ultraviolet light and heats the atmosphere. Then in the mesosphere, the temperature drops again, and the polar mesospheric clouds form at the very coldest place in the mesosphere, near the mesopause, the top of the mesosphere. And they form at these areas where you have cold temperatures because it needs to be cold, of course, in order for water vapor to condense. So that mesopause region is about 50 miles up above the surface of the Earth at what we often refer to as the edge of space because the atmosphere is getting so thin up there. And just to put these clouds into context, these are pictures of other clouds that you are certainly familiar with, some maybe not with others, but cumulus clouds about a mile above the surface of the Earth or so, cirrus about 6 miles, And then there are the polar stratospheric clouds. So these are in the stratosphere about 12 miles above the surface of the Earth. These are very important for ozone processing and in fact are responsible for the ozone hole. And then there are the polar mesospheric clouds that are way up here 50 miles above the surface. Okay, so PMC.
Just below the Arctic Circle, evening skies are filling with pale blue ripples. They appear just after sunset or just before sunrise and are called noctilucent clouds or NLCs. NLCs are Earth's highest clouds. Seeded by meteoroids, they float at the edge of space more than 50 miles above the planet's surface. The clouds are very cold and filled with tiny ice crystals. Those tiny crystals do a good job of scattering blue light from the rising or setting sun, hence their electric blue color. A recent study by AIM science team member Mark Hervig and colleagues, published March 2016 in the Journal of Geophysical Research, confirms that the mesosphere, the atmospheric layer where NLCs form, has gotten colder and moister in recent decades.
If 99% of the atmosphere by volume is below 50 miles and the atmosphere is locked to the rotation of the Earth, then why do all the layers going up to 50 miles move at different speeds and move in different directions? Let me ask that again. If 99% of the atmosphere is below 50 miles and the atmosphere is locked to the rotation of the Earth, then why do all the layers going up to 50 miles move at different speeds and move in different directions?